Welcome to the BA Knowledge Share. In this episode, we will talk about what data models are. So in terms of the data models, by definition, a data model, it describes the entities, classes, or data objects relevant to a domain that the attributes that are used to describe them and the relationships amongst them to provide a common set of semantics for analysis and implementation. So as an example, if you're a business systems analyst and you've gathered the requirements for an online payment system, so essentially after your requirements documentation or during your requirements documentation, you would collect or analyze a set of fields associated with the payment system that needs to be incorporated online. So those data fields end up being part of the data modeling effort, where you, in some instances, you would have a data modeler assigned to a project to help with modeling the data that you've gathered in terms of requirements, or you could have more of a developer or a technical tech lead to sort of help with the data modeling effort. So that being said, in short, when we talk about data models, they really describe the categories of data that need to be, where all the data elements or the data fields need to be bucketed under. So think of it that way. So in terms of the data models, there's three things that are important to keep in mind. There's a conceptual data model, there's a logical data model, and then there's a physical data model. So what is a conceptual data model? A conceptual data model is basically covers the what of the data element. So it's independent of any solution or technology and can be used to represent how the business perceives its information. So as an example, the business might say, for my online payment system, we would like to get or the credit card information or the payment information. So they might say, give you a field like payment, right? So that is more of a conceptual data model as to what they'd like to see. Or another example could be you create some wireframes, and on the wireframes, you sort of define the fields that the business would like the users to see or the customers to see. And on the wireframe, they describe the field as payment. So you know that as a business analyst, there could be different types of payments. So then that gets into more of the logical data model. So logical data model is an abstraction of the conceptual data model that incorporates rules of normalization to formally manage the integrity of the data and relationships. It is associated with the design of a solution. So think of logical data model as your next step of designing a data model. So in the first conceptual data model, you as a business analyst have secured the payment field as an example. In the logical data model, you're basically going to be concerned about, how do you further interpret the payment mechanism. The third type of model is a physical data model, which is used by implementation subject matter experts. So in this case, as I'd mentioned earlier, it could be a technical lead, it could be a data modeler, or it could very well be a developer doing this work. And they basically describe how a database is physically organized. It also addresses concerns like performance, concurrency, and security. So three things to keep in mind in this section are conceptual, logical, and physical data models. So moving on, what I do want to show you are some examples of the two types of data models that are very popular. One is the entity relationship diagram, and then the next one is the class diagram. So what is an entity relationship diagram versus a class diagram? There is not much of a difference. And so it's how you represent the associations, the relationships, and how things are drawn out. So in this example right here, this is an entity relationship diagram. So at the very top of this entity relationship diagram, in terms of these boxes, these are your entities. So what is an entity? An entity is mostly a category. An entity may represent something physical, such as a warehouse, something organizational, such as sales area, or something abstract, such as product line, or even an event, such as an appointment. An entity contains attributes and has relationships to other entities in the model. So this apparel size would be your entity, product would be your entity, product categories would be your entity, and anything over here, color categories would be your entity. And underneath that, you have your attributes like size ID, size code, sort order. So as an example, going back to the payment example, you would maybe have like a payment entity, and underneath that you would have different sort of data elements, and the data elements could be payment type, payment ID, payment expiration date, so on and so forth. Now, if you go to the class diagram, so let's do a side-by-side comparison. So in terms of a class diagram, entities are referred to as classes. Like an entity in a data model, a class contains attributes and has relationships with other classes. So it's exactly the same thing as an entity relationship diagram. In this example, your shopping cart is a class name, your account is a class name, and underneath that you have your attributes. So a class also contains operations or functions that describe what can be done with a class, such as generating an invoice or opening a bank account. So in this case, you could have an operation of maybe addition of numbers, or even over here as an example, generating an invoice, opening up a bank account. Attributes are part of both of these sort of diagrams. And what is an attribute? I mentioned the attribute would contain names, values, meanings, and descriptions. If you notice between these boxes in this entity relationship diagram, between the entities, there are relationships. So the relationship between two entities may be read in either direction using this format. So in this case, a product may have multiple apparel sizes. However, an apparel size can only be associated with one product. Similarly, for product categories and products, so a product may have multiple product categories. However, a product category can only be part of one product. How would you read product and product colors? Please do comment below and let me know what you think about the relationship between product and product colors. So moving on to the class diagram, the relationships are represented differently. There could be 0 to 1, 0 to many, or 0 to 1, 0 to many, and 1 to 1 relationship. So think of it this way. So in terms of the relationships, the class diagram's a little bit different. So as an example, the relationship between an account and a shopping cart. An account can have one shopping cart associated with it, and a shopping cart can only have one account associated with it. So those are sorts of examples that you want to keep in mind as you try to understand the differences between the class diagram as well as an entity relationship diagram. Something to keep in mind is a concept called metadata. So a metadata is a data model which contains metadata describing what the entities represent. So it's basically it's data about data. So really it's when and why were certain data points created, why were they changed, or when and why were they changed, how should they be used, what's the frequency that they should be used, things about security, privacy. So an account sort of class or an account category, and underneath that you have ID, billing address. So maybe billing address has specific metadata, meaning what should we do about security, privacy, when was it created, why was it created? So it's just something to keep in mind as you get more involved with data models. So that being said, please do subscribe to the BA Knowledge Share website, as well as do subscribe to this channel, as well as visit our Facebook page. The link has been provided below. Hope you have a great day.